Okay, guys, so let's continue from where we stopped last week. Last week I gave you an homework, right? Did you all answer? That's it, right? So it was activity 1.2. It was question 3. Okay, so the question was, they tell you two cars pass a fork in a road simultaneously. Car A travels northeast at 120 kilometers per hour. So northeast will be that direction. So we say the velocity of A is equal to 120 kilometers per hour. And then they tell you car B travels west at 140 kilometers per hour. So the velocity of B is equal to 140 kilometers per hour. So you calculate the velocity of car A relative to car B in magnitude and direction. Okay? So they want you to work out the velocity of car A relative to car B. So what would we do first?
Okay, let's get to know what we're giving first.
Yeah.
And then after we get what we're giving, then we find that the velocity of A.
Before we start that, based on the information that we given, right? We know that we're going to have to split this up into its x and y component.
Yes.
But what are we not given?
The angle. Yeah.
But because they told you it's moving in a northeasterly direction, what assumption can we make? We can assume that it's moving at 45 degrees. So we can say that this angle here is 45 degrees. Now the first thing we will do, we break up both velocity of B, velocity of A into its x and y components. Right? So we'll say the velocity of A relative to the ground along your x-axis will be equal to what?
Velocity of B.
Velocity of A relative to the ground.
That's the one that's gonna have a cos. That's the one that we're gonna have to use.
That's what I was
Yeah.
trying to tell you.
Yeah.
Right?
That's the one that we're gonna have to use.
So
That's
it's
the cos
going
and
to
the
be
sine.
120
Cos.
cos 45 degrees. Does everybody understand how we got to this? Is anybody confused? Okay. Remember that this line here going up can be broken up into its x component and its y component, right? So to get this, if this is your angle, this will be what to the angle? Opposite, adjacent, hypotenuse, opposite, right? So this is your opposite, and this here is your adjacent. Now, what do we use opposite in, and what do we use adjacent in? We use adjacent in cos, and we use opposite in sine. So this here, to get this side here, it will be, so remember this is your velocity of A relative to the ground along your y-axis. This is velocity of A relative to the ground along your x-axis. To work this out, it will be the velocity of A sine of the angle. This will be equal to velocity of A cos of the angle. So you understand how we got it?
Yes.
Right. So you put this in your calculator, what you do? 84 point. Give me 3 decimals. 853 kilometers per hour.
Yes, it's a
Actually got one right.
Right.
Actually got it right.
Yeah. Okay. So velocity of A relative to the ground along your y-axis will be equal to what?
Just to the half.
120 sine 45 degrees. This will be equal to the same thing, which is 84.853 kilometers per hour. So we got our x and y for A. Now let's get it for B. So the velocity of B relative to the ground along your x-axis is equal to what? What did we not do at the start of this? Directions. Right? So I said just for consistency, let's always take up as positive, down as negative, east as positive, west as negative. Right? Which direction is this moving in? Negative direction. Right? So its value will be what? Negative 140 kilometers per hour. then the velocity of B relative to the ground along your y-axis will be equal to?
0.
Y will be equal to 0.
There's no Y here.
There's no vertical component to it, right? So what do we do next?
Now you're about out.
It's,
Velocity of A raised to B, right? And then you have to work that out now with the velocity of A raised to the ground on your. You can basically add it up.
You must use something.
must use the Pythagoras theorem.
Right? We're going to work towards the Pythagoras theorem. But we need to work out the velocity of A relative to B along your x-axis. Then you need to work out the velocity of A relative to B along your y-axis.
Some
That will
vertical
give us the
components and
values
vertical
for theorem of Pythagoras.
That's what I said.
No, you never say x-axis, you never say y-axis.
I said no.
Right. So velocity of A relative to B along your x-axis will be equal to what?
Velocity of 3
B.
and velocity of A
Velocity of A
Relative to the ground.
relative to the ground
along your x-axis
along your x-axis
plus
plus
velocity of
Round.
ground relative to B along your y-axis.
No. Exactly.
No, X. You're only doing X.
X,
now.
why you
I
make
mean
Y?
x-axis, yeah.
I'm just listening to you. This is your homework. Right? So from here, what do we do?
Now you
Yeah,
need to
yeah, you have to change the
You
one,
swap.
this other one.
Try to use the words I would use when I'm telling you, alright? You're gonna make both relative to the ground. It must be relative to the same
Oh,
factor,
okay.
right? So you say velocity of A relative to the ground along your x-axis minus the velocity of B relative to the ground along your x-axis. So what you do after that, you substitute your values. So this here is 84.853 minus
Minus 140.
minus 140. And what you left with?
224.
224.853 kilometers per hour. Now we got the horizontal component here. Let's work out the vertical component.
Sorry, before you go there, the decimals, we almost give it three
Give
places.
it 3, right? Okay. So the velocity of A relative to B along your y-axis would be equal to what?
The velocity of A relative to the ground on the y-axis
plus velocity of the ground relative to B on
the y-axis.
Right. Then you'll do
You'll have to change the relative of E.
relative to the same factor, right? So you say velocity of A relative to the ground along your y-axis minus the velocity of B relative to the ground along your y-axis. Then you substitute your values. So this value here is 84.853 minus 0. So this value here is 84.853 kilometers per hour. Now we got our x and y components for your theorem of Pythagoras, right? So we'll do it here, right? So we'll draw this graph. So your x component is a positive value,
Yeah.
right?
In this one.
So it's going to be moving towards your
East.
easterly direction. So this here is 224.853 kilometers per hour. This is the velocity of A relative to B along your x-axis. Then for your y value, it's also positive. So it will be moving like that, right? So the velocity of A relative to B along your y-axis is 84.853 kilometers per hour. Okay? So now the resultant of this line will basically be that. Yes? Okay. And what is this line? This is the velocity of A relative to B. So if we draw a parallelogram, what would this value be? 84.853. So now we got everything we need to do theorem of Pythagoras. So the velocity of AB squared is equal to the velocity of AB along your x-axis squared plus the velocity of AB along your y-axis squared. Right? When you substitute your values, you're going to substitute here 224.853 all squared plus 84.853 all squared, and then I'm going to square root it 110, right? Because
240.33.
so you end up with 240.33. What is it?
3.
Just 331. 331 kilometers.
I'm not saying.
I got 230. I got 230.53.
Yeah. I got 240.331.
Something not high there.
Right. But maybe you took it to 2 decimals.
No,
When you're
3.
winning 3. You sure?
Yeah, it was 853, yeah.
239.53.
Okay, I use the cosine rule, which I thought we needed to do when you gave us all.
4.
Because
No,
that's
but
the last
remember
thing that
I
we
told you in
calculated.
terms of relative velocity, don't use that. Use it in resultant velocities.
Plus
Right?
84.
Oh, is it?
Yeah, because it becomes confusing if there's more stuff in play. So I told you use this method. And they don't specify, they don't tell you use the cosine method, they don't tell you use the Pythagoras method. It's just basically if you use this one, right? Okay. And then in terms of your angle, we're gonna work out this angle here. Right? So tan of your angle is gonna be equal to the velocity of A relative to B along your y-axis all over the velocity of A relative to B along your x-axis. Right? So when you substitute your values, the angle is going to be equal to 10 to the minus 1.
240.
It's going to be 84.853 all over 224.853,
Oh, yeah.
which is equal to
I don't know how I got this. 2239.
20.67. That's all.
Degrees.
That's it. That's all.
Yeah. Yeah.
Oh,
Maybe
put a 1 there.
I can give you the example. Give me a second.
Guys, anybody? So nobody got here.
What's that?
20.56.
20 point?
20.868.
Why don't you answers are fun?
20.68.
It's 84.853.
20.675.
Yeah, I got 20.675 degrees. Right? So what's your final answer?
20.
How would you write it?
200.
Okay, 240.31.
So you say firstly the velocity of A relative to B is equal to
240.331
331
kilometers per hour.
per hour. And how would you write the direction?
East
East
20.67.
675 degrees.
No.
That's your. Who's completely lost without it yet?
The last one, the
I'm
direction.
not really lost. I just want to know the answers in the back.
Yeah.
The direction they've got it written differently.
For this question, yeah.
Yeah.
What they got it?
Not of east.
Just check out.
That's the same thing. North of east means the same thing.
The angle is different because they took the top part.
So 90 minus that would give you
Which
that
one? The
angle.
one, the next one again. But no, then it's equal 240 to 26.65.
No, 20.65.
Yeah, but there's two ways you can work it out. You can either work it usebenzise engezansi yasiyisebenzisile or usebenzise ngaphezulu.
Because if you look at
So
it,
now
it's telling
usebenzisa le
you
ngaphezulu
off east, right? So
it's
if
gonna
this
be the
is
other way around because it's 8.
your
Come back from
coordinates,
north
right?
to east.
East, west. North of east. So where are they starting from?
No.
From
North
the top.
of
From the top.
east. They're not starting from the top.
It's
north of east.
It's
So you will
it's
start
the
from
north
here,
of.
and then you will move
It's
towards.
a north side with reference to the east.
Yeah, you're moving away from your east towards the north side. It's the same thing as us saying east. So we showing that which 2 points it lies between. They showing the same thing, but it's just different wordings. Okay,
Super.
so you're fine with this. All of you are attempted.
Yeah.
Did you get that?
Yeah. The only thing I use the.
But you got it. Yeah, it's fine. If you want to use it, if you're comfortable with it, by all means use it. But I'm saying I don't want you to go into a question and get stuck with
Get
it.
confused.
Yeah.
I'll rather stick to what you say.
And go with that. Okay, can I take it up? Right, you got it? The other question I asked you to do was
Question 1.3, activity 1.3, question 1.
activity 1.3 question. Okay, so they tell you a bird is flying due east with an s speed of 7. So the velocity of the bird is equal to 7 meters per second. Determine the resultant velocity if a headwind is blowing from at 4 meters per second from east 30 degrees north. Okay, so how would you do it?
That was the trickiness question, yeah.
What?
To getting that
So
the wind
initially, I was
4 meters per second.
blowing this
Like
way.
this. You gotta draw it like this.
Yeah.
And where your arrow would it?
Down.
Down, because it's a headwind.
Headwind.
Right. So your angle will be where? That's 30 degrees. Where will you write it?
This side.
No.
Write it?
This side.
Yes.
Yeah.
Yes. Right? Because they're telling you east 30 degrees north. Right? And then they tell you that the velocity is 4 meters per second. So the velocity of the wind is equal to 4 meters per second. Okay.
Can I, before you go on, right?
Yeah.
How do I know to draw it like that? Like that line, if I don't put it on the start of the 7 meters per second.
If you don't put it like that, if you put it
If I
there,
put it, yes, like
that's
that.
still fine.
That's right.
So like how it's like a
Because
circle.
your calculations will still count to the same thing.
Yeah, so it's like there and there. No, yeah, it's there. You got the wind blowing out this way.
Yeah, but where you put your 30 degrees?
The 30 degrees, it was here, added 30 will come here. No, it'll be 60 degrees here.
Yeah.
Because be 60.
Yeah.
Yeah.
So it should be fine. That should be fine, right? So if you drew it like that, right? If you drew it like so, you said it started from here and then it went like this, right? Remember we said the angle is 30 degrees here. If you have to draw your axis, remember this here is a straight line, right? What's the value of this angle here?
90.
It's 90, right? So the remaining part should add up to what?
180.
This entire line, because it's a straight line, it should add up to 180. 90 plus 30 is
120.
120. So 180 minus 120 will be
60.
60. So this part here will be 60. Your 30 degrees would be there. Okay. You understand that?
No.
You don't understand.
Okay.
Okay, so a bird.
You're looking at the top 30 plus that the bottom 90, which forms 120.
No, I'm not even there yet. Still gone so far.
Just go with the directions. I
Sorry,
think.
guys. Yeah.
Okay.
In the beginning, right, it says the bird is flying east 7 meters per second, right?
Right.
And then we're saying
The wind's blowing.
the wind is blowing.
But no, specifically what wind?
Okay.
Headwind.
Headwind.
Headwind. What does headwind mean?
Okay, so
Yeah, what does headwind mean?
Headwind means towards you. Tailwind means with your direction.
Okay.
You understand?
So it's going to go
So
this way.
a headwind, if this is you, a headwind will fly like that. This will be a
So
headwind.
headwind is
A tailwind
counter.
will be flying parallel to you.
Oh,
Okay? So that's how you also know where your arrow should
that's how
go.
the arrow should be. Okay, right.
so that's my
Tailwind view.
Yeah, that's what my confusion, try to understand it.
because this is how I see it. That's what I'm saying. When I put it going this way, and then I put that line this way.
Is it going down?
No, it's going up.
I don't know.
Because we interpreted it.
So
We don't know what headwind
If
means.
your line is going down.
Yeah.
If your line is going down, it's fine.
Yeah.
So I don't.
It's still a headwind because you took the arrow.
But then where does the angle go? 30 degrees.
Still same.
It's right.
Yeah. Right? But obviously we drew it here because since it's a headwind, it will be making direct contact with the bird. But you'll see when you're still doing your calculations, you're still going to come to the same thing, right? Okay. So, it's fine so far. Right. In terms of direction, so your north will be positive, south is negative, east positive, west negative. Okay. So for resultant velocities, what's the two main things we worry about?
Your X and Y.
Yeah, vertical and your horizontal component. Okay. Must I do it like individually or can I just
Just do it like normal.
do it one? Okay, do it individually.
Yeah, individually, like how we did the longest
Okay.
race, yeah.
So, say your velocity of A relative to the ground along your x-axis will be equal to what? Not A, sorry.
But why are you doing
Velocity.
derivative? Isn't also the resultant?
This is resultant.
Yeah.
Doesn't you say we don't
You can
use the
have
ground?
So I'll just
Yeah.
say x.
Yeah, right.
Velocity of the wind on the x-axis.
X-axis, yeah,
Okay.
yeah, that's what it is.
We need to find.
So you'll use, it'll be 4
Oh.
cos of.
Will it just be 4?
It's minus because it's going down.
It's going down. If,
Yeah, minus,
if
minus.
you had to break this line
It's going
into
down.
its components, right?
Yeah.
This arrow will be moving there, and this arrow will be moving there to give you that direction. Can you see that?
So because it's moving into the negative
Yeah.
plane.
Do you get it?
So all you're doing is you're taking that,
That line that's on the.
I'm
that's
thinking
the
like how we did our
can't you
relative
just,
velocity.
can't you just work out the answer and then change the direction? Same
No.
thing. So you're working out.
Same thing.
Huh?
Right?
Okay.
Okay, guys.
So
You see, if the arrow was pointing up, it like it's going like this here. When you're changing that line there, it was going to be pointing on the northerly direction.
Yeah.
But since the arrow is facing down, it's going on the southerly
So
direction.
can I just say something? So if we got it like this, right?
Yeah.
And like that.
Mhm.
So we're putting it in the negative because this wind is coming down here.
Yeah.
That's why we're making it,
It's a
it's a
negative
negative on
direction.
this side.
Because the arrow is pointing downwards.
Okay.
Okay? And it's moving towards your left side, your west side. Okay?
But all I'm saying is, right, if you work it out, right, for on the x-axis, right, work out the value of your resultant, right? Not resultant, your velocity on your of the water on the water, W is water, wind on the x-axis. You work it out, and the direction you can just change it, make it minus like what we always do.
Okay, let's do it your way. Let's see if we can achieve that.
Yeah.
Okay. What you want me to do?
No,
Let's
just,
do it your way, and then let's see if these answers right.
If you set up to say.
Yeah.
Okay, let's do that. Okay. So to work this part out, how would you do it?
we said
How would you get this part here? It will be this is the velocity of your wind along your x-axis, and this is the velocity of the wind along your y-axis. This should be equal to the velocity of the wind cos of the angle. This is equal to the velocity of the wind sine of the angle. You understand it? Right. So this here now will be equal to the velocity of the wind cos of the angle. But now remember, because this line is moving in what direction?
negative.
It's moving towards the negative, it's moving in a westerly direction. What will be your value or your magnitude? It will be minus
4
4
cos
cos
30 degrees.
30 degrees, which is equal to
3.46.
3.464
3.464
meters per second.
minus. Minus.
It's minus. Right. Then you're gonna say the velocity of the wind along your
So while you're there, right? So what I did was, I said 4 cos of 30 gave you 3.464. However, it's moving in a negative direction, I just change the direction.
Yeah, you can do it, but you see when the questions become more complex and when you have more lines when you are going, like you got 2 lines moving in the negative direction, you have 2 lines moving in the positive direction, you can mix yourself up. Right? So if you're keeping it like consistent and following it, then it will be easier for you, right? Okay, so this here would be equal to the velocity of the wind sine of your angle. So this value here is what?
Minus 4.
Minus 4. Why? Because it's moving down. Right? Sine
30.
sine of
That's it.
30. Guys, you're sure you understand what's going on?
Yeah.
Okay. What you get?
No, it's very
No,
different. Yeah.
2. Minus 2.
You get minus 2 on the
Minus 2.
Yeah, minus 2. Minus 2.
meters per second.
Sin 30 is half. So
Right?
it's minus 2.
So
Yeah, minus.
let's work out velocity of the bird along your x-axis. So this would be equal to what?
7.
So this would just be equal to positive 7 meters per second. The velocity of the bird along your y-axis?
0.
0.
And that's positive 7 because it's moving to the east side.
Easterly direction. Right?
Mm.
Okay. What will we do next?
Now you have to add your horizontal and vertical, your x and y's.
Right. So you'll say the velocity along your x-axis will be equal to the velocity of the wind along your x-axis plus the velocity of the bird along your x-axis. Right? So this here will become minus 3.464 plus 7, which is
3.54.
3 point.
You got 4, but we didn't have the application, we know that now.
3.536.
536.
536.
536 meters per second. So now we're going to do the same thing for your y component. Velocity of y will be equal to the velocity of the wind along your y-axis plus the velocity of the bird along the y-axis. Right? Right. When you substitute your values, what would you get? So here you'd say minus 2 plus 0, which is
Minus 2.
minus 2 meters per second. Now we got our x and y component. What can we draw? The triangle for theorem of Pythagoras. So, okay, your x-axis is going to be a positive value, or it is a positive value, right?
Yeah.
So it will be moving in a easterly direction.
Yeah.
Okay, so the velocity of x is equal to
3.536.
3.536. This here is moving in a
Down.
southerly direction. Okay. So this is going to be the velocity of y is equal to. So now we can say 2 because this, remember, the negative and positive denotes direction. Yes.
Oh, okay, that's
Why we never change sign? It's not related to the ground.
Yeah.
Where?
That on the answer of 3.536. The bottom.
Yeah.
Yeah.
Why we never?
Change the sign on that equation.
This is not relativity. This is resultant.
The resultant.
Resultant is different.
Okay.
Okay. Remember that? Don't confuse yourself. You even told me to. You asked me why I was writing relative to the ground because it's not relativity. It's resultant.
And even if you do it on the relativity, you still get the same answer.
Right. I don't know.
No.
I never did it again.
No, but it will be different because the bottom, you're changing it to minus, you get a different answer. You do relative to the ground. Right, you would.
Okay.
Okay.
Okay, yeah.
Right. So now you draw your parallelogram. The resultant will be in that direction. Agreed? Right. So this line here is also equal to 2. Now you do theorem of Pythagoras. So your resultant will be equal to your resultant squared, the velocity of x squared plus the velocity of y squared. Right? This will be equal to the square root of 3.536 squared plus 2 squared, which is equal to
4.06.
4 point.
06.
First instance and substitute.
0.62.
I have
Yeah,
two.
we do
I'll
this.
give you the answer.
Right, now we need to work out the angle. So we're going to work out this angle. Okay? So, tan of this angle will be equal to the velocity of y all over the velocity of x. Right? You understand this part? Okay. Your angle is equal to shift tan 2 over 3.536, which is equal to
29.46.
29.46, and it will have been 46.
Where are you getting that 4.062 from?
What? Where I'm getting?
I'm trying to find out where you get 4.062 from.
Yes. The square root of this square plus that square.
Wait, this square root of
29.49.
Yeah, 3 nines. That's not 40.
29.492.
Not 40.
It's over, yeah.
The top.
Yeah.
Squared.
That's right.
Nothing to bring
This
on
is
the
right.
later.
4062.
Squared equals to Yeah. Oh, 4.062. Okay. Okay.
Yeah.
No.
Right?
I must have
So
done
this
something
here
wrong
is
the first time.
4.9.
Okay.
What is 4.9?
2.
2 degrees. So, what should be your answer when you're writing it down? So you see your resultant, you write resultant is equal to
4.062 meters per second.
meters per second
East.
east.
29.92 degrees. South.
South. But I don't know if you look in the textbook, they said southwest. I think
Yeah.
they made an
Yeah,
error,
that's
right?
the-
Because if you think about it, it doesn't make sense, right?
Yes.
If the wind is hitting the bird like a slower speed than what the bird is flying, how is he going to make it change its entire direction? Yeah, if the wind was coming at maybe 10 meters per second, then I would say because the force that is hitting it with is greater than the force that is moving it.
I think that's what I bet because I looked at the answer and the direction
Was
was
off.
off,
Yeah.
and then
But you must make it make sense to you as
Then
well.
you don't know if it's in the right line.
Yeah.
So the other thing is, where do we lose the
Yeah.
negative? Like, the velocity.
Once you
of
join
the
it,
line.
your direction
We
is
don't
right.
put no negatives
Yeah,
where.
because remember, it's taken
Yeah,
as negative
opposite
because remember
is-
negative is and positive is basically a direction.
2.
It's not an integer value. Like positive and negative, that's why we say positive, not that something. So when we draw it, you only draw it, but in terms of this, even if you wrote the negative, you would still get the same answer because any negative value squared is a positive.
But
But
your
your angle,
angle will be
Like,
negative.
negative.
it will, yeah,
Yeah.
it's gonna be off. Right? So once you draw this diagram, you can drop the negative sign because it's only used for direction.
Okay.
Anyways, fair. Good.
Okay. Alright.
How many of you got it right?
Together, except for the negative.
But it's there. Right?
I made a mistake. It was substitution. That's why I got the wrong answers.
So you know what? The hard part ideal is interpreting the question.
Yes.
Yeah.
That's
I
always.
don't know what I
always.
said, right? Yeah.
Physics
Drawing
and
the
yeah,
diagram.
science.
Drawing the diagram.
That's the main thing.
Trying to piece
Picture
it
or what they're giving you.
Yes.
Because the small words like headwind, for example, that could change the entire thing completely
Yeah.
after that. And that's, remember I told you engineering science is the story plus its numbers.
Yeah.
You need to understand the story and then you can only start your calculations. Right? But the more you practice, the more you get used to words like that. So, yeah.
I think if we took that diagram, mixed it with that diagram, I think it would actually make more sense.
You took this and mixed it with that.
Yeah. So put together, we understand that birds flying this way, they're coming that way, but ends up going that way. Makes sense.
Sorry.
Yeah.
Sorry.
Sorry. No, what I'm saying is like the bird's flying this way, the wind's going that way.
Yeah.
But then if you mix it with that one, the bird's actually ending up here.
The resultant of it.
That's what I'm saying.
If you want.
If you mix them together, it will actually make more
Can you-
sense.
But you see, when you do mix it together,
Yeah.
it could lead to the part where you end up mixing your numbers and your values and the direction you use it.
So you
But-
need to put in your head.
If the start of the question, because it's resultant, right? You'll know what direction you're working towards. Because you know, like, if this is hitting the bird head on, right? The bird is flying horizontally.
Yeah.
You know its speed, the wind is hitting it with a lower speed than the bird is flying. It's not going to change it by a lot, it's just going to push it down.
Like,
Right? So you know it's going to move in that direction.
Yeah.
Right? So if you picture, even if you aren't even drawing the side of your page, you know that's what direction you're working towards. And then from there you can go there. Okay. So, in terms of relative and resultant velocity, is everybody okay?
Yeah.
There are enough activity questions to go through. Even if I don't tell you to go through it, you can work through it and come to me and tell me how did they do this, why they got this value, direction, this, that. I'll check your method, that sort of thing, okay? I also ask you, did I do example 1.11?
No.
I never do example 1.11. Okay, I'm going to do example 1.11 before we start with projectors. How many
You want
projectors?
us to do it ourselves?
No, this one is a bit, it's 1 o'clock. I want to try and finish projectors today, but I don't think we can finish it. Okay.
11. 1.11.
17 and 18.
compass.
Okay, this is not a difficult question.
It's a high
As
grade
long as
stuff.
you remember all the rules, right? Not the stuff to that. Okay, so this is example 1.11, right? So they tell you a boat is set to sail at 50 kilometers per hour north, 30 degrees east. So it's going north and then towards an easterly direction. So it's moving like that.
Yeah.
Agree? And the angle is
30.
30 degrees. Yeah? You understand that? You fine? Okay. Then they tell you a wind is of 40 kilometers per hour is blowing from west 30 degrees north. From west 30 degrees north. So it's moving down. From west 30 degrees
From
north.
west. 30 degrees
So it's
west.
coming from west and it's
From
going
west?
north.
From
West
west.
See, I don't know why you're confused.
It's-
Even Rohit, when he was talking to me, he also confused it. Like, and I don't know why you're confusing it. Right? That's
So here they're not saying headwind or tailwind, they're just saying wind.
from. Just say if you draw it as a line, no direction, right? How would you draw this line?
From
You will see from west moving towards north. Yes?
Yeah.
And
Yes.
the angle will be
At the bottom.
So west, you're going up to north, right?
you from west you're going up to north.
Yeah.
How much up are you going?
That's it.
30 degrees.
So this here is 30 degrees.
Mm-hmm.
So your line you agree would be like that.
Another way.
That's complete.
That's
Oh,
way out.
oh,
Right? That's the line.
No, I think
Can you draw this thing first? Then
No,
you
what?
can see it.
No.
Draw the X and Y.
Draw the
axis.
X,
Yeah.
X and Y
Then I
axis.
can, now I understand why you drew the line that way.
Yeah.
So it's moving from the ground
Mm-hmm. To
west to north up this
Yeah,
way.
it's
So
going.
this
So
is
you
north,
can't draw the line this
south,
way.
east, west.
No,
Right?
never did that.
It would start from the west and you would pick it up 30 degrees there. So that's my line. Right?
So the arrow will be pointing out.
Why out?
'Cause you
It's
went
flying from the west 30 degrees north.
Not.
If it's flying from
Oh, okay.
somewhere,
From-
it's
from the
moving.
west down. Okay, I
down,
can you
right?
get that quadrant there. Okay,
Right.
okay.
So this value here is moving that direction.
Yeah.
Right? I never read them.
Yes.
What you confused?
no, this is it. I know why.
Yeah, he's
I think what we confusing about was that we assuming west, we're saying from west. We're thinking that basically.
Don't start from that point, right? No, I mean, like, don't say that it's flying from this direction and then it's moving to that direction.
What the angle
We're
was.
trying to get the elevation. It's trying to tell you from where it's starting,
Yeah.
and then you elevate it towards which direction, or it could be towards the south or something like that. You get what I'm saying?
Yeah.
Do you have it?
I do. So I think you need to work with that quadrant. So you work the angle out first, as you said.
Yeah.
And then from there it's moving from the west all the way to the north. So the angle is 30 degrees is moving that way there.
So you'll follow exactly like how the question told you. West, 30 degrees where you pushed it up. Towards which direction? It will be pushed up towards a northerly direction. And because they said from, it will be moving that direction. Are we fine?
Sure.
What are we confused about?
It is from and to.
Yeah, this problem too.
You're going to have to get used to it. You can't change
But
that.
then,
Two means it's
I
moving
think the
towards.
more
Okay,
example
you're
you do.
how I see it, that's how I see to draw that in, is that made me see it clearer.
Yeah.
Because when you're just doing our directions, I would have put that line like this, like the first line also.
Yeah, yeah.
But now when it's in that, you can see that you can't draw a second line like that, it has to go in that quadrant.
Yeah, but the thing is the arrow now. How do you get the arrow?
Yeah,
That's-
I would have put the arrow on the top.
Exactly.
But it's saying-
I would have done the same
But it's
thing.
saying from
Now
west
that's
to north.
Yeah.
So
But
the
not
arrow
as
has to
tall.
be
From wherever it is coming from, it is going in the opposite direction.
yeah,
So we draw a line first,
Yeah.
and
It's
then
like
we draw
this.
the arrow.
It's coming down. This is
Yeah, you can do that. I drew the line first because I want to show you where the line is going to be firstly.
So west-
Yeah.
And then the direction I told you because of the word from. Right?
yeah.
If they said flying due
there is
west 30 degrees north, then it will be moving to the opposite direction.
Okay.
Okay?
Do me a favor, can you give us just, I think to this thing, maybe just another two angles, I know it's not part of the book here, just to get the guys familiar with that.
If I had to ask you to draw something.
Yeah.
Ask us in different ways, like how you said
So,
now.
if I said east 50 degrees south, how would you draw that?
Okay, let's
From east 50 degrees south.
Do you want us to do it and then
Yeah.
you check it? Okay.
Yeah.
East 50 degrees south. So it's gonna be going this way.
Yeah, they'll work.
be like this.
So this is just a separate note, I had nothing to do with the question, right?
It's gonna be like this here.
And it's
Which
gonna be
direction?
pointing, it's gonna be pointing
Towards
to
the center.
Work at your angle first.
It's going to be pointing towards
Towards the center.
the center.
Yeah.
Right.
the center.
Right, because if you have to draw it, if this is your axis, right?
East to south.
Maybe
So east is here, it's moving that way.
North, south, east,
would it be
west, right?
Right.
yeah.
We're starting from
From
east,
East.
Yeah.
50 degrees towards the south.
South.
So we're moving somewhere here, just say 50 degrees is here. So your line will be drawn
Okay,
like that.
Yeah.
okay. Maybe just
Just do that, right?
backtrack slightly. Maybe this say if you start east, you stay start east, you work your way 50 degrees down.
Yeah.
Right. Then that's your dots. Then you from there to wherever you're going.
It's the same thing.
Yeah, but you drew it this way. By saying it going that way, you're saying this is from this that way.
Oh, you mean like I'm going to draw it?
Yeah, but
Like
that
this?
way, yeah,
But
that
it's
way.
at the arrow indicator.
But I never
Yes,
say
the arrow,
where the
What
arrow
I'm
is.
saying is the arrow going is that it's coming from the dots to there. So it's from
Yeah,
there.
if you feel comfortable being like that, to
That's
understand.
That's what I'm saying.
Because see, what I want to do is, I want us to get the line first, where the line is,
Yeah.
right? And
Get the
then
direction,
we'll
get
say
the
where the direction is.
Yeah.
Because if it was just the line, right? This was the line. So we worked it out, we know that the 50 degrees is there,
Yeah.
Yeah.
right? From the question they told you, from. So if you're starting from here, you are moving there. So your arrow will be there. If they said to
Yeah,
east 50 degrees south, then you will put your arrow down.
Yeah.
You understand? Okay, then those words are from, to, ju, headwind, tailwind, all those things. Need to familiarize, and the only way you'll familiarize yourself with it is if you do the examples. Okay,
Yeah, but now you told us what
It means
what?
it means, so we're more likely to figure it out.
Yeah, but it's
That's
easier said
all-
because
that's
you're
all
said when
about-
I'm in class and I'm doing it. It's one thing, when you go home and attempt it yourself, it's another thing.
Because you're saying it because you're explaining how the
Yeah.
question
So,
is
but the
how
only
to-
way you will know whether you remembered what I said is if you actually do it. Okay? So, we got one more leg. Okay, so this here is moving down. Velocity.
Yeah.
Uh,
40.
Going
40.
Yeah.
Current of 40
For
This is wind, velocity of
Yeah,
wind is
wind.
equal to 40 kilometers per hour.
Label the other one 50 kilometers.
And then they tell you,
The boat one
that's
50.
it. That's it.
is it?
50.
kilometers.
Alright.
Current of 10 kilometers being flowing in a direction.
And then they tell you, and a current of 10 kilometers per hour is flowing in a direction south 15 degrees east. What direction is it flowing?
South.
South.
From the south.
50 degrees.
South.
Draw your line.
15 degrees east. So, right, this is 15 degrees. They told you in a direction south 15 degrees east. So where is it moving?
In that direction.
It's moving down.
Down.
Right.
In that direction. Ish.
And then they tell you what the velocity is 10 kilometers per hour. But what we call it?
Understanding it
Equal to 10 kilometers per hour. Do we all understand how we got to
So we
this?
need to draw the arrow.
It's there, just can't see it. Okay. Good. Sure. Everybody now we understand the diagram that was given to us. Now they want you to work on calculate the magnitude and direction of the resultant velocity. Okay. So you know with our resultant velocity, we need to get our vertical component and our horizontal component. Okay. So, must I do it individually or can I do it as the sum of?
Okay.
No, but I'll break it up as we go. You'll see, right? Okay, so the sum, because I need to get used to this because remember something, guys? Your paper is 100 marks and it's 3 hours. If you spend like half an hour writing every single step down, you're gonna shoot yourself in the foot, right?
Yeah.
If you get practice, you know what I told you, the more you do it, the more you get used to it. Like when you look at this, you'll already be able to tell you what you need to use to get your horizontal and vertical, right? So let's do it, right? So your vertical component, first thing, we'll start with this one, the velocity of the wind. Okay, let's break it up into its vertical and horizontal. So you'll agree with me that its vertical component is going like that.
Yeah.
Yes? And you'll agree with me that its horizontal component, okay, yeah, it's going like that. Yes, right? How would you work this out? You would say the magnitude times what?
Cos. So which one? You doing the X or
That's
Y?
fine.
You know why?
Sine, we're doing the y, the
Sine.
vertical
Sine.
component.
The
Right?
t.
So this will be sine of your angle. Right? This one here, which is your x-axis or your horizontal component, will be
Cos.
Cos.
velocity of the wind, your magnitude, cos of your angle. Yes. Cool. Now, see the tricks with these ones, right? If you're working it out in terms of x and y, how you would have done it, where you would have shown your x, like how I showed here, where you would have shown it there. Like you see how I showed these two red lines here, the x part, the y, the y part, the x part.
Yeah.
How would you have shown it here?
Use the dotted line.
Us would be line going up and
You would have shown it, yeah,
yeah, yes.
Because of the
You got the
X.
angle.
right?
And then the
And down.
down.
Yeah.
Yes.
Yeah.
Yeah.
Okay.
No, it would be going up. Line.
Yeah. But upward. Down.
So this will be moving again.
Yeah.
This will be moving.
Okay, yeah.
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 Right?
Yeah.
Fair.
So you're putting them.
How would you work on this? The X component.
Cos,
So the top one would
The
be
X.
cos, yeah,
That's
cos,
opposite.
VB cos.
VB
uh,
cos.
cos.
What is cos equal to?
No. Is it
Cos of an angle is equal to what?
Sine.
It's equal to adjacent over hypotenuse.
Yeah.
You mix
This
it up.
part here,
That's sine.
from the angle is what?
Sine.
Opposite.
Cos
It's the opposite,
Yeah.
right?
Yeah.
So, what you would do is,
You rather use it.
you would rather use that angle, right?
Which is 60.
Well, why can't we just use
Why not?
the
You
sine?
can, but to keep it consistent in terms of your, you see when you do your vertical component, you only got to see sides, right? Sine of an angle plus sine of an angle plus sine of an angle. When you're doing the horizontal component, you only see cos of the angle, cos of the angle, cos.
Otherwise
You
you mix it up.
can do it like how you're saying,
But you
right?
confuse
But
yourself.
don't confuse yourself.
Because then what's going to happen
So
here is now your
then-
angles will start changing. Instead of that, it will be here.
So this will be
60.
60 degrees. No, that's not difficult to. Right? That's not
Yeah.
difficult. So when you're doing this now, it would be. Oh my god.
Okay.
Right? That would be it.
But
Yeah?
that's still the same values in a way.
Yeah, it's still the
Still
same
the same
magnitude,
thing, yeah.
but your angle obviously changed. Right?
Yeah.
So now what would this be? Like how I wrote it here, how would you write it here?
That's cos.
That's the
So
same.
it'll be
That's fine.
And
60
sine.
It will be the magnitude of B
Equals
cos
and
of your
angle.
angle. What? This one?
See?
Same.
B
Sine. It'll be cos?
No, sine.
It will be
Sine.
velocity of B sine
And then.
angle. Good.
Okay, but now, are we required? Will we be required to show the how we got the 60-degree angle or not? No, because it's obvious. Because basically it's some.
Yeah, but if you write it down, you won't get confused later.
No, you gotta write it here. What he's saying is,
Okay, alright.
must he show
Must he
90
show,
minus 30? No,
Yeah,
you don't have to. Where the mark it is, you know when you substitute it here,
Yeah.
they give you the tick over there because you showed up, you got it and then you using it, right?
Okay.
Now, in this instance, how would you write this one?
Which one?
This diagram.
I mean the. Okay. So.
It's gonna be just exactly the same as the other one.
Like how we did here.
Yeah.
So we're gonna work on this angle.
Yes.
Okay. So this angle will work out to
Plus, 75.
75 degrees.
Yeah.
Right? So now this here would become
So you must pull all your, try to pull it down to the x-axis. So it reduces the x-axis to make the.
Keep your angle.
For which
low.
one?
No, you don't.
So
have
when
to.
you add in your line, the red line there, you bring it to the
Direction on your arrow
X.
is looking on.
x-axis. You bring it to that line, the horizontal line.
You're saying that the east to west line.
yeah.
You're saying you're trying to keep your angles on the east to west line. That's what he's trying to say. Because we
Yeah, yeah, you can see that. You can see
down
that
to
because it's
the-
easier to break it up in terms
Yeah.
of these components. Right?
Alright.
Okay. So, okay, because I got this line here, I'm gonna write it above with this, right? So for this line here, velocity of B, cos of the angle. Right? They're moving in the same direction, so it's fine, right?
Yeah.
So for this line here, it would be what?
Velocity of current. Cos.
Same
Angle.
angle. Yeah.
Cos of the angle, and this part here would be
Velocity of current sine of the angle.
do you understand how I got to that?
Yes.
Right? Everybody understands? Everybody?
Yeah, but myself, got a problem.
What?
On the directions of your rays. I'm trying to, when I look at V and W sign, you're going down.
This one? Yeah.
Yeah, but the rest, I can see that.
Going up.
Yeah, I see why that one went up, how you came with that one. But the VW, why it came down?
Because see the direction in which this arrow is pointing. It's pointing downwards.
So when it is,
Oh,
Right?
okay.
So
so follow the.
That's
the
why I told you your
the-
arrow wasn't
the
here,
arrow
but
on
you
your
drew it in
right
and
hand.
they still didn't see it.
Southward.
Yeah.
so you understand that?
Yeah.
Okay. Because this arrow, when you're breaking it up, it should be moving in the direction that this would be moving in.
Okay.
Okay? That's right. Good. So now we can use this stuff, right? So if we are to say, okay, so vertical component, what I told you we use, sine or cos?
Vertical is the y, so sine.
It's sine, right? So all three things over here should be sine. So if you have to write it, you'll say the velocity of the wind, sine of your angle, plus the velocity of the bird or boat or whatever it was, sine of the angle, plus the velocity of the current, sine of the angle. Yes?
Yeah.
Cool. Now we substitute it. But this is where you're negative and positive and in terms of directions. Okay? So this VW value here, this line is moving in what direction?
Down.
Down. So what value will it be?
It's negative.
To be not
No.
positive, negative, positive, negative. Right. So this value would be what?
Negative.
Negative. So this would be negative 40 sine of
30.
30 degrees. Plus VB. Which direction is the vertical line?
Positive.
So it will be a positive value. So this value would be
50,
50,
Sine
sine
60.
60. Plus the current, its vertical component is moving what direction?
Down.
Down. So it will be a
Negative.
negative value. So this value would be
Negative.
minus 10, right? Sine
75.
75 degrees. You put that whole thing in your calculator. You see, the more you do it, the more you'll be able to just look at the line and know how it will break up into its components.
Six
13.642 kilometers per hour. See, now you're getting used to using the calculator too, with longer numbers and sine, cos, and tan and stuff. So, exactly like how we did it here, we're going to do it for your horizontal components. And what trig function we use for horizontal components? cos, right? So the sum of, so the sign here basically means the sum of, right? So I said over here the sum of all the vertical components, the sum of all your horizontal components. And if you want, you can break it up exactly like how I broke it up on your diagram and write on your answer. Okay? So this would be velocity of the wind, cos
Angle
of your angle, plus
velocity of the boat.
cos
Angle
of your angle,
plus
cos of your angle. Okay, let's substitute. Its horizontal component for the wind is moving in what direction?
positive.
A positive direction. So it's going to be a positive value. So what is this value?
40.
It's just 40 cos of
Uh,
That's
30.
30 degrees plus velocity of the boat.
positive.
It's positive.
It's moving. Its horizontal component is also okay. So for all, its horizontal components are moving in a positive direction. So all these magnitude values will be a positive value. So what this value will be?
50
50 cos 60 degree plus the current velocity 10 cos 75 degrees. Put in your calculator, what you get?
62.229.
62.229 kilometers per hour. So what did we work out, guys? We worked out the horizontal and the vertical component. What do we use those two values for? Pythagoras theorem, right? So your vertical component will be in what direction? In your north or southerly direction, right? Because this value is a positive value, which way will it be going towards? North, right? So we'll just draw the line like that, and its vertical component is equal to 13.642 kilometers per hour. And its horizontal component is moving in a positive direction. So which way will we go? East. Right. So this horizontal component will be equal to 62.229 kilometers per hour. The resultant of these two would be something like that. Yes? So now we'll draw a parallelogram. This here is also 13.642. This is 90 degrees. And this line here is your resultant. So, to work out your resultant squared is equal to your vertical component squared plus your horizontal component squared. This is equal to the square root of 13.642 squared plus 62.229 squared.
63.708.
What is it?
63.708. 707.
707
Yeah.
kilometers per hour. That's your resultant. And the angle we work out is that angle. Okay? So we'll say tan of the angle is equal to your opposite, which is your vertical component, over your adjacent, which is your horizontal component. This is equal to 13.642 all over 62.229, and this is equal to
12.365.
you just get it from the textbook.
Yeah.
So how would you like your final answer?
So your resultant
Your resultant
is equal to 63.707, and the angle will be
your units, don't forget your units.
yeah,
It'll be
kilometers
East.
kilometers per hour.
Units per hour,
East
east,
12.365.
North.
does everybody understand what we did here? Slightly a bit shorter than what we did in the other one, right? Okay, even the example, they don't show you this part here, how they got it. But now that you're looking at it, and if you break it up, you will be able to see why it is.
Yeah, I think what.
Wait, let me take this part here. Don't confuse that.
I think with the working out the resultants compared to relatives, I think the resultants are easier to calculate.
Yeah, it is.
Yes.
The relative ones are a bit.
It is easy to work at that.
Yeah. So
Okay.
in the exam, right, this question here will be how many marks?
Zero marks.
You'll probably get a mark for. They won't give you a mark for every angle you worked on correctly. They probably give you like that.
Yeah.
They give you a mark for working on the vertical component, the horizontal component, for
Resultant.
maybe using the formula or the substitution of these values into the formula. That answer there for substituting this the correct way, and then that, and then your final answer. So 1, 2, 3, 4, 5, 6, 7, 8 marks. Sometimes less, but it depends on how long the question is. If they got more questions, it is.
Yeah.
Yeah, sometimes I
The
think
boat's actually faster than what it was actually said.
Huh?
Boat's actually going faster than what it was.
Yeah, because the boat is moving.
it's all positive
Yeah.
directions.
Okay. And then the other one, they asked you to calculate the actual displacement of the boat in 2 hours. Now, what does that mean?
So you take
Distance itself.
the resultant
The distance that it
and
would
you-
travel, right? So all you would do, you'd say this is displacement, right? Will be equal to velocity times time, right? What is this velocity? It's this value that we worked out here, okay? Which is 63,707. Remember something? That your units have to be the same when you do multiplication. If this was meters per second, and if they gave it to you in hours, 2 hours, what would you have to do?
you have to convert.
You will have to convert it, because how this basically goes is your velocity is kilometers per hour. Yes?
When you're saying same, you mean that's in the unit standard line.
The units of it.
Yeah, but it's like that.
So kilometers and kilometers.
Hour and stuff, but let's
Hours in
kilometers
hours,
per
seconds,
hour.
seconds.
That's what you mean.
Yeah.
Yeah.
Well, to cancel it off, so you multiply it by time.
Yeah.
Because this is in hours, whatever time you multiply in must also be in hours. Remember, this hours is in the numerator, it's hours over 1.
Yeah.
You all know that, right?
Actually,
So for this to be removed, that
Has to
will
be in
cancel.
same unit.
And then you're left with a,
Kilometer.
and what is this? Distance. Distance, right? So over here, because we added in kilometers per hour, and the question they gave it to us in 2 hours. So you would say 2, and then you end up with 127.414 yes?
Kilometers.
Kilometers. Not per hour, just kilometers. If they told you 2 hours, but okay, say they give you 40 minutes,
120 minutes.
What if they said 60 minutes?
60 minutes,
Yeah.
right?
120
So
minutes.
if they gave you 60 minutes,
So easy.
that's what
1 hour.
1 hour, right? But if they gave you
40.
40 minutes, do you know how to do conversions of these things?
Yeah.
Okay, when we learned these sign conversions and conventions and units and whatever, we learned something called the stick method, right? So you would draw it like this. So everything here is, this is your numerators, numerator value, this here is your denominator. Okay, I'm going to use that value, right? And show you how you convert it into minutes, okay? So,
120.
so if you were given the 63,707 kilometers per hour, right? You remember the time they told you was 40 minutes, right? You want to convert this hour into minutes. How would you do it? Remember, for something to cancel with the denominator, how will it cancel with the denominator?
Has to be the same.
Yes, please.
No, it will cancel from your numerator when you multiply. Yes?
Yeah.
Yes. So, this is 63.707 kilometers for every 1 hour. Every hour is made up of how many minutes? 60 minutes. So what will happen to this and this?
Well, cancel out.
They will cancel off. And you left with 63,7. So everything on the numerator will divide by your denominator. You're left with 63 or 7 kilometers for every 60 minutes. So your answer, whatever you end up working out, will be in kilometers per
hour. Per minute. sorry.
per minute. Do you understand that?
Yeah.
Okay?
Okay.
That's it. You use this more when you have 2 units in it, like kilometers per hour, meters per second. If you have a straightforward one like meters or hours, that's just a straightforward. Like for every 1 hour in the 60 minutes, you'll either multiply or you'll divide by it.
So it's
Then you
also
still,
numbers.
but then isn't the one final one? Are you still
No, this was just your conversion.
It's not gonna work.
Right? So whatever this number here is, you will take this number,
And multiply by.
you will substitute it here, you will multiply it by the 40, and then you'll end up with your final answer. Because sometimes they do that, right? They'll give you the whole question, right? They'll tell you, calculate the magnitude and the direction of the resultant of this entire system, and leave your final answer in meters per second. Right? And they do that, right? So you'll do everything exactly the same until you come to this point here, right? And you will do this conversion. So if they asked you to do it in meters per second,
Before you see future.
But to make that answer correct, can you put the kilometers per hour, and then can you put 120 in that 40? And can we work out this here so I can take a picture and send it?
why 120 in the 40?
No,
Because it was
he
2
wants to
hours,
see
so
how
I
many
want to keep
he
it
wants
the
to see
same
how
as the
many kilometers
example.
per minute he wants to see.
Oh, okay. So, okay, give me the answer for that.
One 1.062.
Yes.
Kilometers per minute.
It's a
So
simple way
this
to
is
work.
1.062
When you're working out your overtime, you do the same thing.
per minute. You multiply it, that unit and that unit will cancel, and you're left with
127.44.
1.7.44.
127.
Right, the classes.
COVID.
Exactly.
Kilometers.
Minutes.
Right. Okay. That's how we find it.
It's nice.
How we call it.
Challenging.
What is it?
That's done. First one.
Shit. Why should have started projectiles earlier? Okay, but we have to start it out, right? Projectiles is the last thing in kinematics. So far, before I move on, are we okay with relative velocity and resultant velocity?
Yeah.
That's
I think we just
wrong.
need to do examples.
You all need to go over
Yeah.
guys, past your with everything, right?
That's wrong. That's going to confuse people.
This was
You gave me
new.
the numbers.
No. We got kilometers per minute now.
You said
Speed.
minutes.
You
Oh,
see
this
that
year-
in that 20
This
minutes?
year was supposed to be out
Yeah.
because it's distance.
Now it's right.
Now
Is it
it's
still
now
very
you're not
confusing?
confused.
No, now it's right.
Because the minutes are
Yeah.
You know how many years we have to survive with him?
Okay, there. Okay, so we find this. Okay, when you attempt questions on it, you can always WhatsApp me, ask me why they did this, how they got this. It's fine, you can do that, right? I'll always respond to you. Okay, so let's move to page 20.
I had a comment earlier. When you're sitting at home trying to figure out how many kilometers per minute
I know it's working out. It's easy.
Can I take us up?
until you get home.
Yes.
No, it is easy. How are you not working kilometers per hour in traffic?
Everything that's in the numerator of the units needs to be divided to get rid of it. Everything that's in the denominator needs to be multiplied to get rid of it. Okay. Take one, that's it.
No, not yet.
Okay.
What was the question?
Make a percent.
Still out, it's fine.
Take it.
I sent it on the. I sent it already. On the
Okay, guys, I'm gonna stop the video and then start it again, right? I don't need to get too big. I mean, I'm uploading or transferring. It's not a
Just so we can